Friends, good morning. Today we are learning about the mechanism of addition polymerization. There are a variety of the alkene or diene and their derivative are polymerized in the presence of a free radical generating initiator catalyst. First of all, we know what is the catalyst. Catalysts are those compounds which increase the rate of reaction. Here we use a catalyst as a benzyl peroxide, acetyl peroxide, and tertiary butyl peroxide, and etc. As for example, we take a ethene. Polymerization of ethene to polythene that are consist of heating or exposing to light a mixture of ethene means here we take a mixture of ethene and then these mixture of ethene are heated or exposing to the light on it with small amount of benzyl peroxide initiator. In the mechanism of this addition polymerization, there are three steps. First step is a chain initiating step. What will happen in this step? The process is a start with addition of a phenyl radical. How this phenyl radical is formed? Here we take a benzoyl peroxide as a catalyst. This benzoyl peroxide contain the peroxide bond, one bond between the two oxygen atom. This bond is broken and here homolytic fission is occur. That's why these two oxygen contain one electron on it. They accept the one electron by homolytic fission and this radical is formed. After this radical is formed, then one CO2 molecule is removed from it and phenyl radical is formed. Here phenyl radical contain the lone pair of electron is react with ethene. Here what will happen? Ethene is contain pi bond. Pi bond is a very weak bond. This pi bond is a break into this ethene molecule and homolytic fission is occur. These two carbon contain these two carbon accept one electron by this homolytic fission. Then one carbon is contained one lone pair of electron and another carbon is contained one lone pair of electron. This phenyl radical is also contain one lone pair of electron. Electron of phenyl radical and one electron of ethene molecule is joined together and form a bond. They share one electron and they form a bond and this radical is formed. These new and larger free radical are generated into this step. That's why this step is known as a chain initiating step. Then second step is a chain propagating step. As this radical is a react with another molecule of ethene and another bigger sized radical is formed. In this step, जो radical is react with n number of ethene and form bigger sized radical. Here same reaction is occur. This ethene contain the pi bond, and this pi bond is a very weak bond. That's why this pi bond is broken down, and these two carbon is contained 1 electron. They accept 1 electron by the homolytic fission, and one carbon of ethane and one carbon of this radical is share 1 electron and form a bond, and this radical is formed. Then n number of molecule is n number of ethane molecule is react with this radical, and this bigger sized radical is formed. In this step, the repetition of these sequences with a new and bigger radical is carries the reaction forward, and that's why this step is known as chain propagating step. Then last step is a chain terminating step. Ultimately, at this step, the product radical formed react with another radical to form a polymerized product. Here, product radical is formed by a chain propagating step. Two product radical are react with each other, and they lose and they share 1 electron and form polymerized product, and this step is called as a chain terminating step. Then we know some important addition polymers. First polymer is polythene. You all know that polythene are a linear and slightly branched long chain molecule. The structure of polythenes are a linear or slightly branched. That's why they are capable of repeatedly softening on heating and hardening on cooling. And thus these polythene are known as a thermoplastic polythene. There are two type of polythene. First polythene is a low density polythene. This short form of this low density polythene is a LDP. What will happen when n number of ethene molecule is react with dioxygen or peroxide initiator? Here dioxygen or peroxide initiator is act as a catalyst, is react in presence of 1000 to 2000 atmosphere and 350 to 570 Kelvin temperature, and we get a low density polythene. Then this low density polythene is obtained through two processes. First is the free radical addition, and second is the hydrogen atom abstraction. It has a highly branched structure. The property of the LDP are chemically inert, that are tough, but they are flexible, and they are a poor conductor of electricity. That's why they are used in a insulator of the electricity carrying wires, manufacturers of squeeze bottles and toys and flexible pipe. Then second polythene are a high density polythene. High density polythene is formed by when n number of ethene is react with Ziegler-Natta catalyst with 6 to 7 atmosphere and 333 Kelvin to 343 Kelvin temperature, and we get a high density polythene. Short name of high density polythene is the HDP. The difference between high density polythene and low density polythene are catalyst. In low density polythene, we use a dioxygen or a peroxide initiator, and here also atmosphere and temperature is a high. But in the high density polythene, we use a Ziegler-Natta catalyst. That's why here we take a low pressure and low temperature. A Ziegler-Natta catalyst is a triethyl aluminum and titanium tetrachloride. High density polythene does produce that are consist of linear molecule and high density due to the close packing. Means this high density polythene contain the very close packed structure. That's why this polythene has a high density. Such polymers are also called linear polymer. Property of high density polythene is a chemically inert, and they are more tough and hard because high density polythene contain very close structure that are used in manufacture of buckets, dustbin, bottles and pipes. Then second is a polytetrafluoroethane. When n number of tetrafluoroethane is react with free radical or a persulfate catalyst with high pressure, we get a polytetrafluoroethane or Teflon. The structure of polytetrafluoroethane is here. When n number of tetrafluoroethane is react with free radical or persulfate with high pressure, and this polymerization reaction is occur, and we get a polytetrafluoroethane or Teflon. Polytetrafluoroethane has another name is a Teflon. The property of Teflon are they are chemically inert and resistant to attack by a corrosive reagent. That's why they are used in making of oil seals and gasket, and they are also used for non-stick making of non-stick surface. Then polyacrylonitrile and polyacrylonitrile. The structure of polyacrylonitrile is the CH2 double bond CH2CN. When this polyacrylonitrile is a react with peroxide catalyst, n number of acrylonitrile is a react with peroxide catalyst, and will get polyacrylonitrile. The use of polyacrylonitrile as a substituent for a wool in making of commercial fiber like a orlon or acrylan. Thank you.